Good afternoon, everybody, and welcome to the Surface Transforms investor presentation in support of our open offer. For those of you who don't know me, I'm David Bundred, and I am the chairman of Surface Transforms. I have with me today Kevin Johnson, who's our Chief Executive Officer, who's going to do the bulk of the presentation, and Michael Cunningham, our Finance Officer. I'm just going to ask Kevin to take over, but before we do so, I particularly want to thank Hardman & Co. for their considerable efforts in facilitating this. So welcome to you. Thank you to Hardman, and over to you, Kevin.
Right. This is a presentation for the open offer for the fundraising Project Spark that we've been completing. It's a £20 million fundraise, 13 of which is for the manufacturing capacity that we're building. And I'll talk in detail about that manufacturing capacity that we want to build. 5 is for working capital, and that's principally to support the growth in the business that we're seeing. And what's of most interest today is the 2 million open offer that we're supporting as well. And that is to support our retail shareholders. Now, for those that don't know us very well, I'm hoping most of you do. We're one of only 2 companies in the world that make carbon ceramic brakes for the high performance vehicle market. And that includes both combustion engine cars, ICE cars, and electric vehicles, EVs. And our markets are the UK, US, and Europe, principally in Europe, Germany. And we've been in the fortunate position of being able to announce a series of contracts over the last 18 months with 4 OEM customers, and the value of those contracts was 43 million. And the latest one of those is a 27.5 million contract in September last year with a new OEM. And that's leading us to want to talk in detail about manufacturing capacity. Those contracts have been filling up our OEM Cell One capacity, which in combination with our small volume production cell has £20 million worth of capacity revenue in it, and comes, if you like, live and starts to fill up during this year. And as I say, Project Spark is about then adding to that capacity with OEM Cell Two, and that will bring up our revenue capacity up to 35 million during 2022. Now, a very brief introduction to automotive brakes. Again, I'm hoping most of you know this, but I do like to just refresh everyone's memory. We're interested in the bit that stops the car. So you have an engine to make it go and go faster, and you have brakes to slow it down. And as that's the principal reason for slowing the car down, it is a safety critical part. And the most interaction you'll have with the brakes is your foot pressing the pedal. However, all the work is done in that picture in the top right, and it's a mechanical brake. It's made up of 3 components inside that wheel, those being the brake disc, caliper, and brake pad. And the way the brake works is when you slot the pads inside the caliper here, and then that sandwiches the disc face. When you press the pedal, the caliper squeezes the pads onto the disc, creates a friction force, and that's what stops and slows down the car. Now, what we're interested in the brake disc, and in principle, we want to replace that iron rotor, which is on every car in the world has this kind of system on it. So there are hundreds of millions of cars made every year with hundreds of millions of brake discs, and we're interested in the top end of that market for carbon ceramics. Now, if we look at what are the compelling drivers for ceramics and the adoption of them on those high-performance luxury cars, first thing to say is it's now well established. All of these guys, it's not an exhaustive list, but all of these guys on the right have adopted ceramics and offer it on multiple models of their cars. And the main reasons they're doing that, I'll start with the technology. And over the last 2 or 3 decades, cars have been getting principally heavier and faster. And as you're putting more weight into the car and making it go faster, that increases the amount of energy that the car can produce, and therefore the amount of energy the brakes have to deal with. And what you find is for these very high performance models of cars, they're starting to exceed the capabilities of iron rotors and iron brakes. And that's because when they get hot, you start to experience this phenomenon called brake fade. And that means you get a loss of friction force and a loss of brake pedal, which can be unwanted and disconcerting at the very least, but very undesirable from a car manufacturer's point of view. And you can eliminate that by changing that iron rotor for a ceramic rotor. And it works at all temperatures and isn't temperature sensitive. So it gives you that consistent friction force, whatever it's doing. Coupled with that, It's lightweight. So we talk about a weight saving on a car if you swap out the iron rotors for the ceramic rotor of 25 kilos, if you swap out all four corners. Now, as I showed you on that photo, this is unsprung mass. By that, I mean it's mass that's hanging off the chassis inside the wheel. And obviously, you've got to have some heavy-duty components that hold that mass, the heavier it is. Now, if we can take weight out of the brake disc, we can then start to take weight out of the rest of the systems around that. And we talk about saving up to 100 kilos per car, which becomes significant. That's about 5% of a car's weight. And if you're talking about just using one product technology to save 5% weight saving, that's very interesting to the vehicle manufacturers. Now, that weight saving permeates some of the other attributes that's driving the market, principally on the environment. For combustion engine cars, saving weight means you can reduce your CO2 emissions for a combustion engine. And for an electric vehicle car, although there's no engine there, weight savings equal the extended range. So again, very desirable in terms of extending the range of a car. Coupled with that, with ceramic discs, you see a phenomenon where the brake wear on the brake pad wear on the system is dramatically reduced by about 50%. And that reduction in brake pad dust equates to a very important environmental factor, which if you can reduce that brake pad dust, it's probably the most significant pollutant behind the engine of a car. It's bad for the air, bad for the waterways, and by reducing that wear rate, you can reduce the pollution. Moving on to lifetime and total cost of ownership, another trend in the marketplace over the last few decades is the increasing service life of wear parts. So that interval between services is getting longer and longer, and also the number of wear parts is being reduced, and that's been accelerated with electric vehicles as well. Now, ceramics fit into that very well. Everyone would be familiar that when they take their car in, periodically they'll be changing the grey cast iron rotor. That might happen 2, 3, 4, maybe even 5 times, depending on the driver and the driving style for iron brakes. And for a ceramic, they last for the lifetime of the car, under normal driving conditions, I should say. Now, we know that ceramics are more expensive. They're typically about 8 times the cost of a grey cast iron. However, when you add up all of those lifetime costs of servicing costs, replacement part costs for grey cast iron, the inconvenience cost, the labour involved, and you compare that to the total lifetime cost of the ceramic, you can actually start to get a compelling case. And again, that's fitting with another trend in the marketplace where people are becoming more and more switched on, if you like, to the cost during lifetime with leasing models and PCPs and the like. Moving on to quality, back to a weight saving here. If you're taking that weight out of the car, you can significantly improve the handling, the comfort, the refinement of the car, and obviously the performance. And these cars are sold on quality. And then the final piece, if you like, is aesthetics. The look of the car is incredibly important. It needs to be desirable. One of the features of ceramics is that they don't age. They look the same on day one as they do at the end of life for the car. So you get an ageless product, which looks very shiny and has a mirror-like finish inside the wheel. So it looks attractive. Comparing that to a corroded, wearing iron rotor, it's very important for the OEMs that the cars look good. Now that corrosion also adds to a feature to ceramics for electric vehicles. Electric vehicles tend to have 2 braking systems, not just the mechanical one, but also the electric motor in the car. And that electric motor does usually 50% of the work. It can do more, which means if the brake is stood idle, the mechanical brake is stood idle, that corrosion can build up on an iron rotor. And you run the risk of getting this phenomenon called galvanic corrosion. That's where the disc bonds to the pad through corrosion and can cause the brake system to seize. Obviously, that's on a safety critical part, that's undesirable. And it's also inconvenient and creates a reliability issue. So eliminating the corrosion with ceramics eliminates that risk of galvanic corrosion. The final piece on ceramics there for cleaner wheels is, again, back to the brake dust. By reducing that brake dust, you keep the car looking cleaner for longer. And I know it sounds a little vain, but the owners of these cars really do want their cars to look their best for as long as possible without cleaning them. So it's a very important selling point from the OEM's perspective. No, I mentioned it at the beginning. In terms of competition, there's been one monopolistic supplier in this marketplace for the last decade or so until we've become more and more successful by winning contracts. That monopolistic supplier supplies about 200,000 discs a year, with revenues about 160 million. And it's incredibly unusual for an automotive market to have just one supplier. Most OEMs want to have an alternative supply. They want to de-risk that supply chain. They want competition. And they also want to have some capacity growth from having multiple suppliers. And that's really where all the OEMs have been coming from, working with us. And that pull from the marketplace has allowed us to be pulled through. Now, here's a list of the portfolio of customers we're working with. It's been growing and it's a significant number. I'll just explain something around our numbering system. All of our customers are incredibly precious about their confidentiality. It's really about them controlling their marketing messages. They want to be the ones talking about what the new technology is on their car. To protect their confidentiality, we give them a number. So you'll see numbers right through from 1 to 9 there, and some new ones which haven't been given a number yet. But these are all the customers that we are actively working on, who are either using our product and have signed contracts, or have tested our product or are testing it for selection on future models. And so we're very pleased to have about a dozen there. It also gives us a portfolio approach and de-risks the business in terms of being reliant on 1 or 2 customers. Now, I will highlight something about some of these customers and the strategy of the way they're building their supply chains and which ones we have contracts with or had contracts with. OEM 1, 3, which includes the rest of the group of 2 and 4, 5 and 6, are all adopting a dual sourcing approach. Now, dual sourcing in the automotive industry isn't perhaps what you'd expect, where they have a volume for a particular car and they share that between 2 suppliers, either 50-50 or another number. The way dual sourcing works for the automotive industry is it's too expensive to qualify 2 companies or 2 suppliers for that one model of car. It's just not done. So they share the volume between their supply chains by doing it. Company A might take model 1, company B might take model 2, and so on. And they split their sourcing between many of their models between the 2 suppliers. As I say, it's more efficient for them and it gives them that de-risking in terms of having dual sourcing. That's 1 to 6. Now, 7 and 8, I'll highlight, they haven't taken the approach of dual sourcing. We are their sole supplier. And 9's coming along, and they are deciding, but we suspect they'll go down the sole supplier route as well. So that gives us a little bit more security, if you like, with 7 and 8. And the ones we've had contracts with is OEM 1. We had a limited edition car back in 2019, early 2020. And we've also got contracts with OEM 5, 6, 7, and 8. And we're also pleased to be talking about some new OEMs down there with another German car manufacturer, well-known German car manufacturer, a US one, and another European one. Now, where's the value in this business, both to our shareholders and to our customers? Here, I want to talk about us becoming world-class, if you like, and a profitable manufacturing and engineering company. And we want to be sustainable alongside that. And that's being driven principally by these characteristics of our customer values. First one is product. They want the best. They want the best product. They want it to perform very well on the car. We talk about having a product that's superior in terms of its technology than our competitors. And by having better, I'm not comparing grey cast iron here. I'm comparing ceramics to Brembo and ourselves. And we use the analogy here that they make chipboard, we make plywood. They're both made of carbon, silicon, and silicon carbide, but it's how you put them together. And our competitor takes lots of short chopped carbon fibers, about 2 to 3 millimeters in length. And they add a resin to that and pour it into a mold and do a hot pressing process inside a hot tooling mold. And that creates the shape of a brake disc. Conversely, we take lots of long, continuous fibers and knit those together into a 3-dimensional structure and surround that with a very crystalline graphitic structure. Now, the output of that is the longer the fiber, the stronger the material, the more robust it is, and inherently you can get more life. And in terms of the crystalline structure that we put around it, that allows us to manage the heat. And remember, brakes are all about converting that motion into heat energy. And so we talk about our disc in a like-for-like test running 200 to 300 degrees cooler. Now that's significant because there are some applications where even for a ceramic brake, although it doesn't lose friction, it's just overheating the whole system. So running too hot, and that can cause the brake pads to start to break down. It can cause the caliper to break down or the brake fluid to boil. Again, all undesirable. So if you can reduce the temperature of the system by 200 or 300 degrees, that can be the difference between having a product that works or doesn't. And if that's not your issue, and you're just looking to say, well, we want to take advantage of that reduced temperature, we can shrink the size of the disc and make it run at the same temperature as our competitors. But by shrinking the size of the disc, it might be compatible with more models, more axles, so it can go across the range. But not only that, volume of the disc equals cost. So we talk about being able to be more competitive on cost and price as well. Now, pricing's well understood. If I move on to that characteristic, we have agreements with most of our customers in terms of pricing. And in a lot of cases, that goes out right through into the middle, if not the end of this decade. So our pricing's well understood, well fixed, and we are competitive. It's fair to say we can also get it sometimes get a premium for our product superiority as well, and we do that with some of our customers. And we've worked hard then to achieve good margins, and that's principally come from cost reduction. The cost of manufacture has been halved over the last 5 years. We think there's more to come, but we don't factor it in. But that said, with knowledge of our pricing and good knowledge now of our process, we talk about achieving good margins now and sustaining those into the future as well. On capacity, I mentioned it earlier, we have 20 million installed, but we've designed that capacity to be modular because one of our customers' requirements is always, how do you scale this up? And we have a site that is expandable. For those that you've visited already, you'll have seen that. And we talk about then being able to scale our current OEM Cell 1 and just replicate it with OEM Cells 2, 3, 4, and 5. Then onto quality. These are really just statements more than anything else. In terms of quality, we have our certifications to industry standards. You can't drive a car without having a license, and similarly in our markets, you can't operate without having the right quality certificates. And then on terms of geography, we're obviously based up in Liverpool in the Northwest in the UK, and we service the UK customers from there. And then we allocate resources to Germany and the US as and when required. Now on supply chain, this is also incredibly important for our customers. It's not just about us delivering to our customers, but if we can't deliver because of our supply chain, that affects them. We now have a very credible supply chain. We have dual sourcing in place for the raw materials, and we have a very integrated process. So we're buying the precursor to carbon fiber, and we're taking it through quite a number of steps right through to the finished component that goes onto the car. And that also protects us in terms of our IP as well, which I'll come on to. Now, that's enabled us to win a number of contracts, as I mentioned earlier, worth 43 million over the last 18 months. And that started to fill up our capacity in OEM Cell One. And if we look forward through our revenue in terms of what we think's happening over the next few years, those contracts haven't kicked in yet in terms of this year. They will do for series supply in 21. Our revenues last year without that were 2 million, but the growth this year is about 3 of those contracts starting. And then we'll see our revenues grow up to 7 million this year, with a full year effect of that, because they all start around about the second half of the year, with a full year of those revenues and further contracts starting for a series supply, we see our revenues grow to 13 million. And then if we were to cascade that out to 23, just on contracts only and not winning anything new, that would grow to 17 million. Now you'll notice on that bar chart, we've got the blue bar for 23, says that the requirements from our customers is 30 million. So if we look at what we'll talk about in detail a little later about what they call carryover models, where they're going to take the existing product they've already contracted for and put it on new models, or there is a new particular contract we're interested in. We could see that demand, rather than being at 17 million, being at 30 million by 2023. And therefore we have to do 2 planning exercises. We do the first one on our cash flow, P&L and balance sheet by looking at just contracted customers and working out what we should do from that. But then we also have to plan our capacity by basing it on what our customers are telling us in terms of what their requirements are for capacity in the future. And that is telling us that it's going to exceed our current 20 million of revenue capacity that we have. So we need to do something about it. And that's all in the context of having a prospect pipeline for projects that I'll mention later on that comes to about 75 million by 2024. And of course, we talk about this being a growing market. I don't see this as a zero-sum game between ourselves and Brembo, where the penetration into this £2 billion market is still only at 6% as an estimate. And so there's plenty of growth here for not just ourselves, but as Brembo as well. Now, moving on to how we plan our capacities and how we do, and what our strategy is. This is our facility. There's a little photograph of it here. And it's a sort of upside down L shape from this photograph. And I've got a plan view of it here. It's a 55,000 square foot facility. And we've already installed our small volume production cell, the SVP cell, and that looks after our development revenues, if you like, for OE and contracts and the retrofit business we have and our near OEMs or specialist niche vehicle programs we have. Alongside that, we have our OEM Cell One, which we've installed now and is ready to go for those series production contracts that are starting this year. And that gives us our 20 million of capacity, you can see on this bar chart. What we are planning to do now is install OEM Cell Two. It will be a replica of OEM Cell One, so it will be the second module. And that will bring our revenues up to 35 million per year during 22 and 23. And it is fair to say it isn't quite a replica. So we're going to take some lessons learned from OEM Cell One, but we aren't, those are lessons learned on how to build the cell rather than on our supply chain and the design of the equipment. But we'll be taking those and installing it into Cell Two. And then if you look at the rest of site, we talk about it being further expandable for Cell 3, 4, and 5. And if we add those capacities on, we talk about the footprint marrying up quite nicely to what we see as our prospective project pipeline of 75 million per annum. Now, in terms of our planning for capacity, our planning assumptions have always been, and this typically works with OEMs 1 to 7, that we can wait for contract award before we need to plan capacity in and install it, because typically it takes circa 2 years between contract award and SOP and start of production. Now that's great because it takes us about 18 months to then build and demonstrate our production capacity. And so the two dovetail together quite nicely to say that when contracts are given, we can then go and build our capacity, install it, have it ready, demonstrate it, and then start supply. What we're finding is we're particularly with disruptive OEMs like 8 and 9, that behavior isn't being followed. And a good example of this is with OEM 8 contract that we announced last September. So if you think that was circa sort of 5 months ago, we will be in series supply within 12 months from that contract award, sort of between 12 and 15 months. Now, we were fortunate because OEM Cell One had capacity available, so we were able to win that contract with OEM 8. What that means is when we then look at, when we have the fortunate position with OEM 8, that we have carryover models coming. So that means by carryover, I mean we've designed and engineered that product, not for that first car with OEM 8, but there are other cars that are coming which are heavier and faster. And we've designed the product to be sized correctly for the heaviest, fastest type of application. And then, as I mentioned earlier, we've been able to accommodate that on all the platforms. So that what they'll do at OEM 8 to minimize cost and compress their timelines is they want to carry that product over onto 2 subsequent models. Now, we don't expect them to award those contracts in the typical timeline. They'll be awarding them probably 12, circa 15 months out, which means if we look at the planning of our capacity with those carryover models, it takes us beyond OEM Cell One's capacity and gives us a problem, albeit a nice problem to have, is that if we don't build capacity, we won't get the contract, but we can't wait for the contract to build capacity. So that's what's causing us to take on Project Spark now, rather than following our normal assumptions where we wait for contract award. Similarly, OEM 9, is a competitor to OEM 8, and they behave in a very similar way. They're a new entrant. They're launching cars this year and next year. And we're working with them as well as the system supplier for that car, where they want to launch the car with an option and as a standard fit on a second model for next year. And again, that doesn't, if you look at the capacity we need for the demand from OEM 9, it takes us beyond what we've got available in OEM Cell One. And we don't expect them to be working off the typical 2-year timeline. They're compressing it. And it means we're in the same position where if we want to win that contract and supply it and be successful with them, we have to take decisions on capacity now rather than wait for that contract to come in. So if I look at how that capacity then sort of pans out on an annual basis, as I say, in 21, we have the Aston Martin contract for Valkyrie, Koenigsegg contract with Jesco starting, and we have OEM 8's Model 1 starting in 21, and that's what's driving our revenue growth in 21 to circa 7 million. And as I mentioned earlier, if you then carry over those models into 22, plus the new contracts with Koenigsegg and the first contract we have with OEM 5 starting in 22, that would drive our revenues to 13 million. But if we add the potential contract with OEM 9, that could take us up to 20 million and start to exceed our capacity, particularly when you look at the monthly run-up rates of that capacity requirement. Now, adding in the carryover models for OEM 8, again, takes us beyond that initial capacity if it was on its own in OEM Cell 1, so there's a need to do it anyway. But in terms of timing, it would be additive in 23, and that takes us up to circa 27 million. And we also have carryover models from a similar way with OEM 5, which would take us up to just shy of the 35 million capacity we're installing at 34. So really just with current contracts, carryover, and OEM 9, we can talk about completely filling OEM Cell 2. Now, if something was to happen to one of those, so to de-risk what we're talking about, we have a pipeline of programs coming through by 24, again, with a series of OEMs and new customers. So we feel like that's de-risking any decisions we're making on OEM Cell 2. And also, we have to have a second eye on our capacity planning, because if you add all those up with those existing models for carryover and current contracts in OEM 9, that takes us up to that 75 million by 2024 per annum as a prospective contract pipeline. And we've got two things here. If we were to win all of those contracts, we then know that our supply chain, not to make parts now, but the supply chain for building modules and manufacturing cells, wouldn't be able to cope with building cells 2, 3, 4, and 5 altogether. It just simply can't be done. So building Cell 2 now also allows us to de-risk future capacity requirements and frees up that capacity in the supply chain for 22 and 23 and 24, as and when we're successful with those future models that we're working with our customers. Now, a little bit of detail on OEM Cell 2. As I mentioned earlier, that capacity addition will bring us up to 35 million of capacity revenue during 22. And that's all of our decisions in terms of timing are being driven by this term called off-tool off-process during 22, if not by the middle of the end of 22, 23. And off-tool off-process for us means that our customers, before they go into series supply and the start of production, they ask all the supply chain to freeze what they're doing, to stop making any changes or optimizing things. So you stop changing your processes, stop changing your tooling or refining your tooling, and don't change your equipment. That's what off-tool off-process means. And so we want to be ready for that, so we are able to be prepared for that milestone to be reached. Now, construction costs for Cell 2 are circa 10 million. Michael will give you the exact number a little bit later. And if you look at the payback on that cell, at full capacity, it's about 15 months. Now, the detail of building a cell is really driven by the critical path for furnaces and fabricating and building and testing those furnaces. We want to start that process now so that we can complete the selection process of the supply chain to build the furnaces we want and the long lead items. Now, I mentioned it earlier, we sort of know what we're going to do with that, but there is a competitive tender process we want to go through to ensure that we're doing the right things in terms of buying these expensive pieces of kit. So we want to close that out by spring 21. And that allows then the supply chain to start fabricating furnaces and so forth during the summer and autumn of this year. And they should be ready then for us to start to work with them by the end of this year, winter 21-22, where we can start doing the on-site acceptance testing at the supplier's site. One of the things we have learned from Cell One is that we had some furnaces that we did a lot of testing at the supply site before we accepted it, and others we decided to do it on our site. And it's fair to say the ones where you do more exhaustive testing before it arrives makes the commissioning and installing of the equipment go much more smoothly. So we want to learn from that. That means that we'll be in good shape then for spring next year to bring the kit on site for Cell 2, install it and commission it, and then we can demonstrate the capacity and the run-up rates and so forth that we need to for our customers during the summer 22 and beyond. Now, I'll just hand over to Michael and he will take you through a couple of slides.
Thanks, Kevin. Okay, so just talking about the use of proceeds from the fundraise. As you can see, we have a small amount that's required for Cell 1. That's for resilience in the manufacturing process. The majority of the money is for the manufacturing capacity in Cell 2. Of that, about 2/3 is for furnaces, so just over £6 million. 1 million of it is for infrastructure, and the other 2 million is for ancillary processes within the sale. In addition to that, we're raising 3.1 million for manufacturing resilience and for some development equipment that's required, giving the total capital expenditure of £13 million. In addition to that, we're looking for some working capital to support our rapid revenue growth. As you can imagine, with our volumes going up, there's a massive increase in work in progress. Our stocks are there. We wish to hold buffer stock to de-risk the projects with OEM 8 and OEM 5. And in addition to that, we'll have a significantly increased debtor book to fund, given that US manufacturers in particular work on a sort of 60-day end of month. So that gives placing the subscriptions total of about 18 million and a proposed open offer then of 2 million, giving total proceeds of 20 million. Obviously the timeline that we've gone through is the record date is the 19th of January. We close payment and settlement on the 5th of February. Result of the open offer RNS is on Monday the 8th. And the dispatch of share certificates should be on Wednesday the 17th of February. So just going over the trading update that we released 3 weeks ago. We had our revenues were in line with expectations of 2 million, which is, as you know, better than what we had expected in April when we did the fundraise at that point, where we thought we would come in at 1.6. So we've had quite a successful period during 2020, we believe, given the circumstances, and we believe we've had no downtime whatsoever due to COVID, and we believe we've got a very robust COVID secure environment for our employees, allowing us to have some security and comfort for hopefully going forward for the rest of this year. At the end of the year, we had cash of 1.1 million. And as usual, we expect to add 0.6 million of R&D tax credit in 2021. That should come in about June, July time. And our current borrowings are 500,000. Of that, 200,000 is soft loan with our local authority through their investment vehicle, and the other 300 is asset finance over the CNC machines, which you will all be aware of. And as Kevin said, obviously all of our OEM contracts are progressing according to plan, and we're on track for capacity series supply in the middle of the year.
Yeah, thanks, Michael. Right, so if I could just summarize then. We've talked about our multi-year recurring contracts, and we've been announcing those over the last 18 months. They're worth 43 million. And by multi-year, just to remind everyone, some of these contracts go right out till 2029. So they really are recurring revenues for us. That's driving our revenue growth. And I mentioned earlier where we can achieve good margins. and that's leading us towards profitability and a positive EBIT. And all of that is in the backdrop, as I mentioned, about the project pipeline in excess of 75 million within the next 5 years. Michael's mentioned our trading is in line with our expectations, and the other part of our day job, if you like, is doing the business planning. And I talk about the two scenarios, managing the commercial risks in terms of the business, and we do that by just talking about contracts only, and looking at our cash flows and P&L by just contracts only. But I think you're starting to get a flavor that if we just do it by that and plan our capacities the same way, we would fail to deliver to our customer requirements. And so we do a second planning scenario where we have to look at what the customer demands are in terms of manufacturing capabilities and capacity. And that is driving our decisions with Project Spark and the capital investment required. When we look at those current contracts with carryover models and OEM 9, we need more capacity. We need to build Cell 2, and we need to do it now so that we can manage our growth and the customer demand and our supply chain. And that's why it's driving our timeline and our management of the risks there. It is a 10 million investment for the cell, and as I say, payback for that cell, if you do it at full capacity, is 15 months.